kind of, even though as you're working on that 10, 11, and 12, that you are kind of making sure that, that if you're not sure about something and it's on 12 or 13, to just know that that next week when you come in, you are taking your tests over on that Thanksgiving week. So next week we have a full week. That Thursday or on Friday is going to be open time for you to come. But then when you go into that week of Thanksgiving, you guys will be taking your tests that Monday. Okay? So the key thing really is as you're looking at the rest of this week, it's just kind of keeping up and then trying to, is to do this, because it's office hours the whole time. And I know some people have it as intervention, like you have to come and be there. My thought is if you show up and I have a few different people in algebra, I might put you in a group and say, okay, I want the 4 of you to look at these questions and let's work them through and talk to each other. And then I bring you back into the group, right? So we do some breakout groups with that. So that's kind of my plan as I'm looking forward to. Today be 3, 4, 6 all need work. You need to show me how you got the slope. You need to show me the point slope, and we need to go from there. Okay? Questions on any that I could look at there in Google Classroom. So we talk about what a sequence is, generating the nth term. So if you think of those when you saw a list of numbers, that's a sequence of numbers, right? So down here are some examples of sequences. We are going to be looking at writing what's called an explicit formula. We're also going to be looking at doing what's called a explicit and recursive formula. And we start with the explicit. So we are looking at vocabulary. We want to write down that a sequence is an ordered list of numbers that often form a pattern. We call each number a term or an element of the sequence. And a sequence is a function whose domain is the natural or counting numbers. So when we talk about the domains, we talk about the natural counting numbers. That's because we are talking about term 1, term 2. So when we talk about this number and I'm looking at this sequence, this is my first term. This is the second, the third, the fourth, the fifth, right? So natural or counting numbers. We don't say, oh, this is the 0 term, or this is the, we don't go integers, right, negative. We are always looking at how many terms. So we call that, when we talk about that domain, the domain is always going to be the counting numbers or natural numbers. So if you think of counting, that'd be like 1, 2, 3, right, going on. So on the bottom page of this one, we talk about these rectangular numbers. So notice the first rectangular number. So this is my first term, second, third, fourth rectangular number. So when I look at this table over here, I say, oh, n, that's my term 1, gave me 2 dots. The second one, I can see 6 dots. The third one, 12, the fourth, 20. And we might try and think of, is there a pattern as I'm looking at this, right? And some of you might be thinking, you know, if I took 1 times 2, I get 2, like thinking of the area of that rectangle. And so what would be the area of the second rectangle? 2 times 3, that gives me 6. And the next one, 3 times 4, right? 3 times 4, if we are looking at that. Oh yeah, that gives me 12. So could I, without drawing this, get my pattern of the next numbers? So this one is going to be 4 times 5. So try those next ones, please. 5 times 6, 6 times 7, 7 times 8, 8 times 9, 9 times 10. So it says, what is our pattern that you're filling in? The pattern was 1 times 2, 2 times 3, 3 times, okay? We start with 2, and each time as I look at this table, we could say, oh, I added 4, right? So if I'm going down this table, It is definitely not linear, right? Because here I added 4, and I don't add 4 the next time. Now I add 6 to get the next one. And I add 8. And could I check that? Yeah, that's an adding 10 and adding 12. So I can see that it keeps adding a certain number each time, okay? So we've completed our table. It says, is the ordered pair a function? So thinking about that definition of a function, each input has one output. Is it a function? Yes. We don't have any the same, like 2 doesn't give us 6 and 2 doesn't give us 10, right? Yes, each input has an output. The domain, what kind of numbers are we talking about? Those are our counting, we call them, or numbers, or our natural numbers. How many dots would the 10th figure be? We didn't get that far, right? But if we were looking at this, here is kind of the pattern that we are looking at, is that if this is n, you took n times 1 times 2, which is n plus 1. Does that make sense? You took 1 times 2. If we check that out, here we had 6 was our n, and we took 6 times 7. Okay, so 6 times 7 gave us 42. So if we were looking for the 10th number, what do we need to do? We need to take 10 times 10 plus 1, 11. And 10 times 11 gives us, if we are looking at that, 110 dots. So it says, write an expression that models this. Well, if we are thinking about this pattern, and this is n, and we said, oh, you always take that number times 1 more. So if I said, what's the 20th one? You'd say, oh, that's going to be 20 times 21, right? This is our pattern. So when we look at that, if we're going to write an expression, when we write that expression, we might write it as, and this is different notation than you've seen before, right? We've used y and f of x. This says a sub n. Write it as a sub n. Is it a function? Yes. This is our pattern. What does the n stand for? Whichever term you want, okay? If we were going to find the 100th number, what does it mean to find the 100th number? That means I'm going to put a of 100, which means I'm going to go to this equation, and I would put in, instead of n, I'm going to put in 100 times 100 plus 1. So if you have your calculators, 100 times 101 is what we're doing. So we would write our answer as a of 100 is equal to, did you get it?
Well, I just have a question.
Sure.
So how do we write the a of 100?
You just replace wherever the n is with 100.
So, okay.
So it's a here, but instead of n, we put 100.
So it's like below the a.
Right. It's like a subscript is what it's called in mathematics, or in science, a subscript. So anyone got the 100 times 101? What'd you get?
10,100.
10,100. So if we are looking at that, use those calculators. They're going to come in handy as we're doing some of these. 10,100, and we are done. Okay? The special notation to show sequences, similar to the idea of function notation. So the 10th triangular number is 55. Therefore, we say the 10th term in the sequence is 55. And this is how we write it. We write t sub 10. We don't, so which just means when we read that, t sub 10 equals 55. It means my 10th term is 55. Okay? So if I listed 1, 2, 3 up to 9, the 10th one is going to come out to be 55. The little number, the 10, is called our subscript, so that kind of answers your question you were talking about. Or it's sometimes referred to as the index. It indicates the position of the term. So it's trying to tell us this is our first term, right? This one is telling us it is our fourth term in the sequence. So that if I was listing it, I might have seen this list looking like this. I might have seen this. 1, 3, 6, 10, right? That's what the sequence looks like. This is how we write it in this notation. So it's just that different, okay, thinking about it. Key things, sequences are functions. Their domain is always natural. 1, 2, 3, 4. We can represent them using function notation and sequence notation. So when we talk about how they look, usually in function notation, a lot of times they might use F or G or, okay. In sequence notation, when we are talking about it, we usually use a T. So if we're looking at that, we have T sub n, whereas a function is f of x. These are the same thing, just written differently. Place it with 20. So we're going to put 20. Someone said, do I have to write 20 plus 1? At first I would. Divided by 2. Which really means I have 20 times 21 divided by 2. Now I am not going to multiply 20 times 21 because I can simplify first. I know 2 goes into 20. 2 goes into 20 10 times. 2 goes in here once, and that's a much easier multiplication, right? 10 times 21 gives me 210 for my answer. Finding our nth term. And if I would have asked you to find the 0, what would 0 be? 0 would be 0, right? Because each time what we are doing here is we should have had 16 and 25. We're writing those square numbers. 36 and 49. Well, what if it's n? That means it is n squared, right? What did we do to each number? We took it times itself. So now it says, we do not want to make this table through 250, right? This said, what's your 250th term? That's what this is asking. That means we're going to go to our notation and we're going to say a sub n equals n squared. The 250th term means, take out those calculators please, 250 to the second power. Now, what you really might be thinking is, what is 25 squared? Just writing a little bit, but it really happens tomorrow and the next day. Lesson 10 and 11 is where we get into right now. So it says a recursive formula is a piecewise defined. That's why we did piecewise functions, right? We had one piece and another piece, so it kind of links us into this. There's a first term, where we just say, what is the first term equal to? And then there's a rule. So there's two parts. Always the first term, and then this is the rule, okay? So we're going to always put in our starting value, and then you fill it in with the expression that shows how did you get the next term. Notice this says n equals 1 because it is the first term. Why does this say n greater than 1? Because you're looking for the next term after 1. People are like, why do we have to say that? Because mathematically, that's how you have to write those equations. So, here's an example. It says, as we look at this, here's the sequence. 40, 20, 10, 5, 2.5. You're going, oh, they're taking half each time, right? The first term was 40. We write that here. The first term is 40 when n equals 1. Now, a lot of times it says behind that that's optional. You don't have to write this part. This one is required. You have to have this in yellow. Why? Because now we're looking for the pattern. Oh, this right here just says, and I know everyone kind of freaks out, what is n minus 1? This just means the previous term. So think about this. The first one is 40. If I said, well, what about the second term? You'd say, oh, you took the previous one. What was the previous one? If I'm on the second? The previous was 40. And what do? You divide it by 2. That gave us 20. what if I said, well, what is the fourth term? Right? This is my first, second, third, fourth. If I wanted the fourth term, and I said, what's a sub 4? That means I take the previous one. The previous to the fourth is the third term. My third term is 10. The previous divided by 2. Did it give me the fourth term? Yes. The fourth term was 5. That's all that a to the n minus 1, that's all that means. It's just the previous one. Like what came before the first one, right? So if it's a sub 1 is the first, n minus 1 is the one before it. It just means previous, okay? So it takes some getting used to, like the notation, okay? So the last part, I think what I'm going to have you do is you're going to watch this in the video. And for both of these two, and I want to help you with some homework, okay? So you're going to watch those two in the video, and I would like you to turn. So the next one, should you be able to tell me the third term? I think so. Should you be able to tell me the sixth term? What does it look like it's happening from 2 to get to 6, 6 to get to 18, 18 to get to 54? What are we doing each time? If you're looking at that, anyone see the pattern? We are multiplying by 3. So if this is my first, second, third, fourth, fifth term, how do I find g sub 6? For g sub 6, I'm going to take 162 and do what? Take it times 3 to get that answer. Okay. So 1, 2, and 3, do them, kind of check those answers. I want to look at 4 through 7. 4 through 7 says list the first 4 terms of each sequence. We're going to start with number 4. Please write a sub 1. We have to find a sub 2, a sub 3, and a sub 4 of each one. Okay? So as you do these, you have to find all 4 of them. We're going to put that list here as a sequence. We're going to list them, right? That's my answer, is going to be the list of those 4 numbers. How do I find the first one? I replace this n with, what do you think if I am looking at that? What should I replace it with? So, what should I replace the n with when I look at this?
3.
So 3 times what?
N.
No, what number did I put down here for my n?
1.
1, so 3 times 1 minus 4. So I'm going to multiply 3, subtract 4. 3 minus 4 gives me negative 1. That's my first term. So see, we're going to go to the second one, a sub 2. Tell me what to write. Yes. So 3 times 2 gives us 6. 6 minus 4. My next one is 2. Andrew, you ready to give me the next one? What I should write for a sub 3?
3 times 3 minus 4.
Yes. Gives me how much?
5.
5. Can some of you see the pattern that maybe you don't substitute in the last one and you go, oh yeah, I see this now. It's 1. I added how much, Nathan, to get from negative 1 to 2 and 2 to 5?
3.
I added 3. So am I adding 3? Oh, that's my rate of change. That's my slope, right? So this is almost like slope-intercept form, right? So that's why we did those forms of equations. So now if I add 3, I might not substitute in 4, but I should get 8. Should they check if I would put in 4? Yes. Okay? Does someone want to pick an... so we're going to do 8 together. So, Olivia, it tells us to find p sub what? In number 8. P sub 4. That means every place where there's a 4, right, in number 8, I'm going to replace it with, or every place where there's an n, I'm going to replace it with 4. So tell me what to start writing, Olivia. All divided by 6. Now some of you might be thinking, why would I put 4 plus 1? Couldn't I put 5? Couldn't I put 6? Yes. But sometimes when you're writing it, I think it is very helpful to use the original. So you have 4 times 5 times 6 all divided by 6. Let's divide 6 by 6, right? 6 divided by 6 is the same as 1, and 4 times 5. My answer is 20. Let me check the back. Now the one that we haven't talked a lot about, and I think you're going to be okay as you watch the video and you look at these, and again, this is what we'll answer questions on. In question number 10 that you're looking at, it says he wants to find if he diets for 8 weeks, what will his weight be? That's the same as this, right? You're trying to find W sub 8. This is the one that's a little different. This is a solving equation one. So I want to start you with that one, and then the rest of the time, I'm going to just be walking around and trying to help you with whatever I can. So this one says he is going to be dieting in order to get at 103 pounds. He's a wrestler, probably, right? Has a certain weight. It says here is the function. So please write that. W sub n equals he's losing 1.5, 1.5 pounds per week, and he started at 110. And the question is, when will his weight be 103? If I just asked you to solve that for n, Carol, what would you do first for solving for n? I want to find what n equals. So this is going back to like the first week of this year. I have this equation. 101 equals negative 1.5n plus 110. I want n by itself. What would you do?
Distribute.
No distributing. What do I do to get rid of 110? Do what?
Minus on this side.
Minus 110 on both sides, right? I'm like, oh, I get negative 7 equals negative 1.5n. If I am solving this, Claire, what do I do to find n? 1n. And that makes sense because negative divided by negative is going to give me a positive, right? So n is equal to, and I'm going to do that division. Now, could we have subtracted 1.5 from 110 and just seen how far it was? You could have done that also, but this is solving it algebraically, and we get 5 weeks. Meaning, could I have said, someone said, okay, 110 minus 1.5 pounds, that means they're at 108.5. Then I'm going to subtract another 1.5 pounds, they're down to 107, right? They could have done it that way too by subtracting 1.5 and found what the fifth one was, right? So, as you're looking at this gets into writing the sequences. I want to help you however I can. Keep checking those answers and take a look